Alkenes are useful intermediates in the synthesis of organic compounds. Complete the elimination mechanism by drawing the appropriate curly arrows. Okay, so we're given one of the curly arrows already. The carbon-carbon double bond, I'm just going to highlight a few bits. Carbon-carbon double bond is going to form here. So this bond here is going to break. So curly arrow, so I'm going to take this hydrogen off here. That's going to form with that bond there. And then we've got our other bond there. Okay, so there'll be 1 mark for that, 1 mark for that curly arrow there as well. I'm just going to rub my green bits out, my thinking or my working out that I've done there. So complete the elimination mechanism. Curly arrows. Sorry, it's just going to be 1 mark for that, I would think. 1 mark for both arrows that are drawn there. So draw the structure of the E and the Z isomer for hex 3-ene. So we can see that it's in the middle. So let's draw my carbon-carbon double bonds first, like this. And I've got CH2, CH3 on each side. So the Z isomer is going to have them on the same side. So CH2, CH3, H3C, H2C, and then hydrogen and hydrogen. So they're on the same side. So if they're on opposite sides now, CH2, CH3, and you could draw this like this just to show you alternatives, CH2, CH3, hydrogen and hydrogen there. Connectivity will be key here. Okay, so 1 mark for each correctly drawn isomer. Okay, so state the meaning of the term stereoisomers. So stereoisomers have the same structural formula. But the atoms will be arranged differently in space. So 1 mark for that and 1 mark for that. And then D, the equation for the first reaction in the conversion of hex 3-ene to hexan 3-ol is shown below. So we've got sulfuric acid, outline a mechanism for this reaction. So CH3, CH2, CH, CH, CH2, CH3, with sulfuric acid, double bond in there. My advice is to always draw it out displayed like this and do your curly arrows that way. But if you're, well, I'll do this in the next step on how you shouldn't write sulfuric acid. And again, the exam board are pretty strict with this. So curly arrow from there to there, curly arrow from there to there. So that's going to be 2 of the marks. And then that's going to give us our intermediate. So it doesn't matter which one you put it on, they're both going to be the same. So CH3, CH2, CH. So if I put the hydrogen on here, plus CH2, CH3. And what I'll do now is I'll do the OSO2OH with the lone pair and the minus sign on here. You cannot do this OSO3H. That will be marked incorrect and that will be wrong. So they are not allowing that. Okay, so never write SO3H. It's always got to be SO2OH to represent the SO2 here and then the OH over there. Okay, so rub this out just to make sure that people don't think that that is okay. And then the final curly arrow in this one is from there to the carbonyl, to the carbocation, which then gives us CH3, CH2, CH2, CH, CH2, CH3, and again down here I'm going to have OSO2OH. So 1 mark for this arrow, 1 mark for that arrow, 1 mark for the correctly drawn intermediate, and 1 mark for the curly arrow coming from the correct structure of sulfuric acid.